Hey guys, welcome back to my YouTube channel. Myself Vivek, studying in Information Science and Engineering, 6th term, Sri Venkateshwara College of Engineering, Bengaluru. So today let's see about extendable hashing in a file structure. So basically, what is extendable hashing? Extendable hashing is a dynamic hashing technique that allows for efficient storage and retrieval of data in a hash table. It addresses the limitation of traditional static hash tables, which have fixed size and can suffer from collisions and increase access time when the table becomes full. So this is extendable hashing. In extendable hashing, the hash table starts with a single directory that contains a fixed number of pointers to the buckets. Each bucket can hold one or more key value pairs. Initially, the directory has a small size. So in the beginning, it will be having a small size, typically containing only few pointers. So this is about extendable hashing. The hash function maps the key to a binary value. This function maps the key to a binary value, and a portion of this binary value is used as an index into directory to locate the corresponding bucket. The number of bits used as index determines the number of buckets in the system. So the number of bits which is in the index, that determines the number of buckets in the system. When a key needs to be inserted, if the corresponding bucket has a space, the key value pair is simply inserted into the bucket. However, if the bucket is full, the directory is expanded by duplicating the directory entries and allocating new buckets. So basically here, if the bucket is when the bucket is full, the directory is expanding the duplicate directory entries to add new buckets. How extendable hashing works? The key idea behind extendable hashing is to combine conventional hashing with another retrieval approach called the trie. Trie is also sometimes referred to as a radix searching because the branching factor of search tree is equal to number of alternative syllables that can occur in each position of the key. So this is how extendable hashing works. The radix of the alphabet. Suppose we want to build a tire that stores the key Abel, Abrams, Adams, Anderson, Andrews, and Baird. A schematic form of trie is shown in the figure 12.1. As you can see, the searching proceeds letter by letter through the key. Because there are 26 symbols in the alphabet, the potential branching factor at the every node of the search is 26. Turning the trie into a directory, where we use striers with the radix of 2 in our approach to extendable hashing. Such decisions are made on a bit by bit basis. We will not work in the team of individual keys, but in the terms of bucket containing keys. Suppose we have a containing keys that Suppose we have a bucket containing keys that, when hashed, have a hash address that begins with the bit 0. Bucket B contains key with the hash address beginning with the 10, and a bucket C containing keys with the address that starts with 11. Figure 12.2 shows the trie allows us to retrieve these buckets. So the next one is, how should we represent the trie? Rather than representing the trie as a tree, we flatten it into an array of continuous records, forming a directory of hash address and pointer to corresponding buckets. Step 1. The first step in turning a tree into an array involves extending it so it is a complete binary tree with all of its leaves at the same time, as shown in the figure. Even though the initial 0 ones enough to select a bucket. The new form of a tree also uses the second address bit, so both alternative lead to the same bucket. So this is how we should represent the trie. And the step 2 is, once we have extended the tree this way, we can collapse it into a directory structure. Now we have a structure that provides the kind of directed access associated with hashing. Given an address beginning with bits 10 and the 10 directory entry gives us a pointer to accessed bucket. So these are all the steps. Splitting to handle overflow. The goal in extendable hashing system is to find a way to increase the address space in response to overflow. Suppose we insert records that causes bucket A in a figure to overflow. In this case, solution is simple. Since addressing beginning with 00 and 01 or mixed together in a bucket A, so we can split bucket A by putting all 01 address in the new bucket D, while keeping only the address 00 in A. We must use the full 2 bits to divide the address between two buckets. We do not need to extend. So here only we need to divide between the two buckets, but we do not need to extend the address space. We simply make full use of address for information that we already have. So this is all about splitting to handle overflow. So finally, conclusion. In conclusion, extendable hashing is a dynamic hashing technique that addresses the limitations of static hash tables by allowing for efficient storage and retrieval of data. And it achieves this by using a directory of pointers to buckets where each bucket can hold one or more key value pairs. The directory starts with a small size and expands as needed. So basically it starts with a small size and expands as much as needed. So this is the conclusion to the extendable hashing. Thank you. Myself Vivek M. Please do watch and like my video. Thank you.